Hello students, in this video we will talk about some of the chemical reactions, how we write down the rate of a reaction and rate of disappearance of any reactant and the rate of formation of any product. See, suppose this is our reaction here, this is a reaction here, a reactant A, it changes into the reacts with the B and forms C and D. These are the reactants here and these are the products. From the balanced equation we can say that the time in which 1 mole of A reacts in the same time period 2 moles of B are consumed, right? So we can say therefore rate of disappearance of B, right? Because with time concentration of B will decrease. So rate of disappearance of B and rate of disappearance of A is not same, right? That's not same because more B is consumed than A. The time period in which 1 mole of A gets converted into product, in the same time period 2 moles of B are consumed. So the rate of disappearance of B and A are different. And how much they are different? Rate of disappearance of B, we can say it is 2 times the rate of disappearance of A, right? So we can say this is 2 times the rate of disappearance of A, right? Similarly, suppose if you want to relate here the C with A, right? The time period in which 1 mole of A is consumed, in the same time you get 3 moles of C, right? So rate of formation of C, right? Rate of formation of C is not equal to the rate of disappearance of A, because the time taken for 1 mole of A to get converted into product, in the same time period you get 3 moles of C. So therefore we can say rate of formation of C, right? Rate of formation of C is 3 times, right? It is 3 times more than the rate of disappearance of A, correct? Similarly, let's suppose relate the D with the A, okay? A with the D with the A. So rate of disappearance of D is quite different than the rate of formation of D is quite different than the rate of disappearance of A, and that is 4 times the rate of disappearance of A. So rate of formation of D is 4 times the rate of. In the last video we discussed how to write down the rate of a reaction first, correct? We discussed how to write down the rate of a reaction. Suppose we have the same reaction and we can write down the rate of a reaction in terms of each reactant and in terms of each product. Suppose rate of a reaction in terms of A, it will be minus change in concentration of delta, change in concentration of A by delta T, right? So the rate of reaction in terms of B, again minus change in concentration of, it's 1 by 2 here because the coefficient is 2, change in concentration of B by delta T, right? So in terms of C it will be plus 1 by 3 change in concentration of C by delta T, which is plus 1 by 4 change in concentration of T by delta T. If we look at the relationship between the A and the B, the whole term here, this A and B here, how they are related, right? So this whole term here is the rate of a reaction, right? This is the rate of a reaction in terms of B, correct? So I can write it like this. I can take these two terms out and I can say this if I say minus change in concentration of A by delta T, right, into 2. If I take this 1 by 2 to this side, it will be 1, it will be 2 by 1, right? So just into 2. That will be equal to minus change in concentration of P by delta T. So what is this thing? This is not a rate of reaction, this is the rate of disappearance, right? This is the rate of disappearance, right, of B, right? It is the rate of disappearance of B. So that is basically the 2 times the rate of disappearance of A. Okay, this is the rate of disappearance of A. So let's take another example. I think it will be clear from that. Okay, so let's take another example here. For example, we have a reaction H2 plus O2. They form the water. It forms the H2O, and this is 2 molecules, right? And we can also say this is 2 times, right? So this is the balanced equation. You can write down the reaction rate here, rate of a reaction in terms of hydrogen and oxygen, right? So we can say this minus 1 by 2 change in concentration of hydrogen by delta T, and that is minus change in concentration of O2 by delta T, and that will be plus 1 by 2 change in concentration of H2 by delta T. Now see, suppose if you want to write down the rate of a disappearance of hydrogen, correct? Say rate of disappearance of hydrogen, right? Rate of disappearance of hydrogen means change in concentration of hydrogen by time taken for the change. Without this term, right? Without the 1 by 2. It becomes, it's a rate of disappearance, right? So once we multiply it by the 1 by 2, it becomes rate of reaction. So this is how the rate of a disappearance is different than the rate of a reaction. That means this term here, right, is basically the rate of disappearance, correct? Similarly, this term here for the oxygen, if you want to write down the rate of a disappearance of oxygen, O2, that's again here the same thing, because the coefficient is 1, so it will be the same, right? So we can say this is the rate of a reaction as well as the rate of a disappearance of O2, right? So in terms of oxygen, it's the rate of reaction and rate of disappearance of O2, because the coefficient is 1. And the rate of formation of any product, rate of formation, suppose rate of formation of water. Okay, formation means we are going to write on the plus sign. Without this coefficient, right, without this coefficient here, okay, that is the rate of formation. So that means the change in concentration of water by delta T. This is the rate of formation. So this is the rate of formation of water, right? This is the rate of formation, but once you multiply it by 1 by 2 by the coefficient, it becomes the reaction rate. So let's take a couple of more questions on it. Suppose we have a reaction N2O5 decomposed into NO2 and O2. Rate of disappearance of O2 is this much, okay, and we have to calculate the rate of formation of oxygen and NO2. So these are the two things that we are going to calculate, correct? The first thing that we will do here, we are going to write down here the rate of a reaction in terms of each reactant and each product. That will make the thing simple for us, right? So the first step, you get this type of a question, write down the reaction rate in terms of each reactant and each product. That is the first simple step that you should take. So reaction rate in terms of N2O5, we can say it is minus 1/2 change in concentration of N2O5 by delta T, right? And in terms of product here, it is plus 1/4 change in concentration of NO2 by delta T, which is equal to plus change in concentration of O2 by delta T. What's given now? Rate of disappearance of N2O5. So that means this thing is given, right? We know this part, this portion we know, and that is this much, right? We have to calculate the rate of formation of NO2 and O2. Let's first of all calculate the reaction rate. We can do so many things from this particular example, right? Let's first calculate the reaction rate. Rate of reaction is this much. You can see here reaction rate is 1/2 in this one, and can I say it is 2 times the reaction rate? Reaction rate, that will be minus change in concentration of N2O5 by delta T, right? If I take this thing to this side, it will be 2 times the reaction rate. So we are left here with the reaction rate, rate of disappearance of N2O5, and that's given. How much is given? That is 6.25, correct? So 6.25 into 10 power minus 3. That is the rate of disappearance. And you can also now calculate basically we can now calculate the reaction rate. Again, the reaction rate, that will be divided by 2. Therefore the rate of reaction will be this whole thing, 6.25 into 10 power minus 3 by 2, right? So that will be half. Reaction rate is half the rate of disappearance of N2O5. Now, but the question here is, what is the rate of formation of NO2 and O2? So the reaction, relation here, we have to find out between the N2O5 and O2. So that means from this equation, just looking at this equation, N2O5, rate of formation of N2O5, I think, that will be change in concentration of NO2 by delta T, right? That will be 4/2 times the change in concentration of N2O5 by delta T, correct? I'm taking this 1/2 to this side, it will be 4/1, right? So it will be 4/2, correct? So 4/2, right? So it can be, I can also write it as this is 2 times the rate of disappearance of N2O5, right? Because this thing is rate of disappearance, right? So that means rate of formation of NO2 is 2 times, this is the rate of formation, okay? This is the rate of formation of NO2. That is 2 times the rate of disappearance of N2O5. Similarly, we can also do it for the oxygen, okay? So for oxygen also we can calculate from these two things here. You again look at these two things, N2O5, this one, and this term, right? Rate of formation of rate of formation of O2 and rate of disappearance is given, correct? So if we multiply by 1/2, you will get a rate of formation of NO2. So rate of formation of O2 is basically, that is minus 1 by 2 into change in concentration of N2O5 by delta T, right? And this thing is given, this much is given 6.24, so it will be 6.25 into 10 power minus 3 by 2. That is the rate of formation of oxygen, correct?